kind of an internal clock that, from doing it over and over and over again, we know, where the temperature range is. She's squeezing in that center, really getting a nice shape. So the key is to keep working the glass really hot. So before it gets too cold, she'll go back into the reheating furnace and get it nice and warm. Now you can actually see inside of this furnace, we have a camera mounted behind it, and it's looking through a really special type of glass. It's called fused silica. This is actually an old window that we took out of the reheating furnace. Sometimes when they're in there a long time, they get a little bit hazy on the surface. So fused silica was actually developed right here in Corning in the 1930s by a doctor named Frank Hyde. And when he invented it, they didn't have a use for it. And if you go watch the video, it's out there where the telescope mirror is. There's a video that plays, and he talks about developing that type of glass. And he says that sometimes there's an incubation period where you invent something and they don't have a use for it until years later. And that's what happened. When NASA came along, they needed a type of glass that would withstand very high temperatures that you could see through. So they used fused silica. And today, they primarily use it for fiber optic cable. She's going to get that really hot, stretch it out this time. You can really tell the experience of a glassmaker by how hot that they work the glass. She really has a lot of control, and she works the glass very hot. See how much it's moving around? Sometimes he even gives it a little swing to stretch it. You can really see it lengthening now. Now when she blows into the iron, you can see the bottom of it. That's the part that's inflating because that's the hottest area of the glass. I mean, naturally, when she goes into the reheating furnace, the bottom, it's a lot hotter towards the back of the reheating furnace, so that area gets hotter a lot faster. There's a bunch of fans up here, sometimes it's hard to hear. So we're actually using electricity to heat all of our furnaces up here on this stage. Now that's very unusual. And why that is because the museum about 5 years ago was partnered with a company called Celebrity Cruise Lines. So we had a hot shop on the 15th deck of 3 cruise ships. And when they came to us and asked us about putting a demonstration on the top of a cruise ship, usually people reheat the glass with a barrel of fire called a glory hole. So it's the same type of reheating chamber, but they use gas instead, so it's a flame. And they don't like flames on a cruise ship, so they actually developed an electric reheating furnace. Actually, the museum has a patent on that design. All right, I think Katie's ready for the foot. She's going to cool this down a little bit, and we're going to drop some hot glass on it. Now we have another hot shop on the other end of the building called the Amphitheater Hot Shop, and all of their furnaces are run off of natural gas and forced air. So they actually work a bit different than the equipment up here. We like to say it's like cooking on a gas stove compared to cooking on an electric stove. If you cook and you have used both types, you can tell a big difference in how they work. So we're going to drop some hot glass on the bottom of this, and we're going to flatten this into a nice wide foot. So we're going to let this cool down just a little bit. You can see I kind of let the glass run off the iron a little bit. That's the only usable glass. I'm going to bring it right up to Katie, and she's going to grab it with the shears. You can see how quickly it runs right off the tip. She cuts off the amount that she wants, and now she'll sit down and shape and center with the graphite paddle.
ऊपर देखो ये तो आगे अड़ गया.
We're going to work together to, to create a nice flat foot for our base to stand on.
अब इसको काटेगी कैसे वो देखना.
Yes.
What are the tubes made of that they're not transferring heat?
Well, you know, the tubes do transfer heat. If you look about a third of the way up, you can see where they're discolored, and that's where they get really hot. They're made out of stainless steel, which is a poor conductor of heat. If this was made out of mild steel, the heat would travel farther up the iron. We like to use stainless, for one, because it doesn't conduct heat as well as the mild steel, and it also doesn't rust. So that's a big factor. You don't want to use a rusty iron. Your hands get all rusty and
इसका कलर
yeah, it's not very good. Now we're going to transfer it to the punty iron. So I'm going to take a little bit of glass on this solid rod, and I'll shape it on the table to cool it down. Now I'm going to point this up quite a bit. Katie right now, she's just taking a flash. This is just a quick overall heat to make sure that the whole piece stays warm enough where it doesn't crack and break. The glass that's connected to the iron, that's called the moil, what's holding it on the end of the rod. And if the moil gets too cold, it'll start to crack and break, and those cracks will run right up into the piece. So we have to keep the temperature really consistent as she's doing this part of the process. So she sticks it right in the center, turns it to make sure it's in the middle. Now she's going to add a little drop of water to the jack line, and a slight little tap in the vibration will break it off onto this iron, just like that. And you can see the small hole left in the front from the blowpipe, so we're going to go back to the reheating furnace and start to work on the top.
वो आगे थोड़ा अच्छा नहीं लग रहा है ना, उसको दोबारा से गरम करके उसको ठीक कर देंगे.
Now that really is the hardest part to learn when you first start making glass. To make sure that the whole piece is the right temperature, to attach the putty at the right temperature, and really a lot of it just comes through experience, doing it over and over and over again. Like I said, we put that putty on the bottom, we attach it at a temperature where it'll come off easily at the end. So once we're finished shaping the top of it, we have to remove it from the bottom. If the putty's stuck too well, we call that fusing it onto the bottom. It's going to want to break a big chunk out of the bottom of it when we go to take it off. On the other hand, if it's not stuck on there properly, it's going to fall on the floor before we're finished with it. So I'm going to get Katie's tool out called the Sophietta. This is a bent aluminum cone, and she can still inflate the top of the piece once she's off the blowpipe. So we have this cone so we can use, insert it into, any size hole up until the diameter of that, and then she'll inflate the top of the piece where she's been heating it. And again, this is a really good indication of the temperature. You'll see when she comes out, she's been focusing the temperature right on the top of the piece.
आप क्या देख रहे हो? इसमें चश्मा कैसा लगा रखा है देखो.
Has anybody gone down to see the new opening of New Glass Now? It's a really fantastic show. I mean, we're making glass up here. We're making objects like bowls and vases and cups and things like that to show you the process. But, most of the pieces down there, all of the pieces down there are using glass as an artistic expression. So it's pretty amazing to see how people today are using glass like this for art. Now you can really see she inflated the top of that quite a lot. That's a really interesting shape right there. She could stop there if she wanted to. She's going to start to heat this and stretch it open. You can see how versatile those jacks are. The first thing she'll do is put the piece all the way inside the furnace to make sure that the punchy stays hot. Then she'll come back and focus the heat on the top of the piece. Sometimes we'll do that just before we sit down too. We'll give it a quick flash on the punchy. Look at how soft the glass is. She can pry that right open. And again, she could stop there. That's a really nice shape also. I think she's going to heat it one more time. And I think that she's going to make a beautiful handkerchief base out of this. So by getting the top really hot and turning a little bit faster, centrifugal force is going to start to open it up almost like a plate shape. When she comes out, she'll hold it towards the ground, and that'll give her a beautiful fluted edge all the way around the top. Pieces like this are fun to watch because you see a lot happen. You can see, look at how soft it's getting. It almost wants to fall in on itself, and she picks up the rotation, spinning faster and faster. There it is. And look at that. She gets that beautiful fluted top. Fantastic. Now it's already starting to cool down because she made the vessel very thin. It's cooling very quickly. You can see it's already losing its temperature. We're going to put a couple drops of water on the connection, a little tap, and the vibration will break it off onto these forks. Just like that. And we're going to fire polish the bottom where we broke it free. There's a little sharp edge. So we're going to fire polish that and then put it into the oven to cool down overnight. Like I said, it takes about 12 hours to cool a piece this size. How about a big round of applause for Katie Hubbs? Nice job.